All right, so this video is going to look at area of rectangles and squares. And this is not new for you, but we are going to just take a little bit of a look because we're going to use some of our prior knowledge and understanding to be able to do more with the area of rectangles and squares. So we want to start by talking about the difference between perimeter and area. Just as a quick reminder, perimeter is going to be your distance around a figure. So imagine that a person is walking and following the path of the outside, right? That's your perimeter. And so our units are going to be things like centimeters, inches, feet, miles, meters, etc. Whereas area, we know, is the total space inside a two-dimensional figure. And we have to be a little bit careful because when we talk about the units for area, it's similar to perimeter, but we're talking about centimeters squared, inches squared, feet squared, miles squared, meters squared, right? So it's the square units. So we need to make sure we're careful there. So as you guys know, when we think about a rectangle, we are thinking about the length, let's say, of the base of the rectangle. So how many units do I have along that base? And then how many units do I have along that height? And that will allow me to count the total area of a rectangle, which is the number of units in the base times the number of units in the height. So that's why we say base times height. Same idea for a square, but as we know with a square, when we're talking about the number of units in the base and the number of units in the height, we're talking about the same exact length. So side and side are going to be the same. So that means the area of our square is going to be side times side, which is side squared. So when we do this, we might need to apply some of our prior knowledge. We might need to take shapes and break them into smaller shapes. So let's take a look at this one. This one's asking us to find the total area and the total perimeter. So if I take a look at the perimeter, I need to figure out this missing distance, this missing distance, and this missing distance. And that will help me find the perimeter. If these, it says specifically that these are all right angles. So what that tells me is that this side also has to be 10 centimeters. And then if this is 10 centimeters, this whole part right here, and this part is 4 centimeters, then this part is also 4 centimeters. And then last but not least, if this whole part is 5 centimeters, this is 1 and this is 1, 5 minus 1 minus 1, that leaves us 3 centimeters right here. So to find my perimeter, I can go ahead and just add up my total distance around the shape. So 10 plus 5 plus 10 plus 1 plus 4 plus 3 plus 4 plus 1. I basically just went all the way around the shape because that was a good way for me to stay organized. Why does that say plus 41 plus 3 plus 4 plus 1 is what that's supposed to say. And so that gives us our perimeter when I add that up, 10, 15, 25, 26, 30, 33, 37, 38. So 38 centimeters is our perimeter. Now, when I am considering area, I'm going to have to break this into a couple of different shapes, and there's a few different ways I could do it. I could either break it into this square and then 2 rectangles, or I could break it into 2 rectangles here and then this middle rectangle here. It's really whatever feels easiest to you. To me, I feel like it's easiest to go like this. So if this is already 4, then this leaves me 6 here. So my area of this box is going to be 30. Okay. Then I have 4 by 1. That's an area of 4. And then 4 by 1, that's another area of 4. So when I add those up, my total area is going to be 38 centimeters squared. Making sure that that units is squared is really important. Now, when I'm finding the area of a rectangle, we need to know the base times the height. In this example, I do know that the height is 5 centimeters, but I don't know what this base is. But because I have this nice right triangle, and I know the diagonal or the hypotenuse is 13, I actually notice that this is a 5, 12, 13, and I can go ahead and identify, oh, this is 12 centimeters. So now I know both my area of my base and my area, the length of my base and the length of my height to get my area, which is going to be 60 centimeters squared. That's some of our prior knowledge, our triples coming into play here. Now when I look at determining the area of a square whose diagonal is 12 root 2, when I look at this one, the first thing I'm going to do is I'm going to draw my picture. And my rectangle at first did not really look like a square. I'm doing my best. And it says my diagonal is 12 root 2. Now there's something that we know about squares from our quadrilaterals unit, which is that this diagonal bisects this angle. So both of these angles are 45 degrees. So if that's the case, I have to use my knowledge about 45, 45, 90 triangles to go ahead and solve for my missing side. I need to know what that side is to find the area. So I'm going to put down my ratio, 1, 1, root 2. And then this would be x, 12 root 2. And so here's my ratio. I'm going to go ahead and cross multiply. So I get 12 root 2 equals root 2x. And when I divide both sides by root 2, I get that my side of my square is 12 meters long. But that didn't answer my question yet. My question is actually what's my area of my square? So I'm going to go ahead and say area equals 12 times 12, which is base times height, or 12 squared. And that gives me 144 meters squared. So just thinking about these last two problems, in both problems we had to use our prior knowledge, we had to use our understanding of right triangles, Pythagorean triples, 45, 45, 90 triangles, etc. Now, we have two more questions we're going to look at. In this example, This is one of our examples about taking parts of our area away. You've definitely done this kind of thing before, but it never hurts to do a little refresher, and it also never hurts to talk a little bit about how you can communicate what you're doing here. So I am going to go ahead and name my rectangles. And here's why. It's going to make it easier for me to communicate what I am doing. So if I wanted to find the area of my shaded region, I know I can find the area of rectangle ABCD. That's going to be 10 times 6, which is 60. I know I can find my area of rectangle EFGH. That's going to be 4 times 2, which is 8. And I know I can find my area of IJKL. That's going to be 3 times 2. Right? For each of these, we're doing base times height. Now, I found the area of all these rectangles, but really I want to know the shaded region, which is going to be the entire ABCD minus the other 2. So 60 minus 8 minus 6 is going to give us the area of the shaded region. And when I calculate that, I get 46. And I need to make sure I put my units. I should have a square centimeter because we are talking about area. So it's super important that you are communicating what you are finding so that your work can be easily followed. Now, the very last problem we're going to look at, we have to make sure we read carefully. It asks us to find the perimeter of a square. So I know that the area is 36, but I don't know what my sides are. Now, if I'm going to find the perimeter, I need to know what my sides are. Well, the area of a square is going to be base times height, but both base and height are the same. So sometimes we call that x times x or x squared. And so I can figure out that, oh, well, if I square root both of these, I know that each side is a length of 6. But it didn't ask me for the length of the side. It asked me for the perimeter. And I know I have 4 sides. So I need to add up 6 4 times to get that total perimeter of 24 centimeters. All right, this has been a review of area of rectangles and squares and some perimeter and how we can apply our previous knowledge to that.